Finding the solution or finding the value for a linear function is nothing but linear programming problem. What is this objective function? The linear function z, where you are going to find the maximum value or minimum value of that equation is nothing but objective function. You should substitute value of x and y by taking the coordinates. So for the first one, x is 0, y is 0. So when you substitute here, the whole equation becomes 0. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Here in this session, we are going to study a very interesting chapter, linear programming problem. So what is this linear programming problem? Linear programming problem helps us in many ways to find the maximum and minimum values of a linear inequalities. And here, we are going to learn about the LPP, that is linear programming problem, and how to formulate it by mathematical linear inequalities. So, let us take an example. So, for example, the dealer invests his money buying the tables or chairs or both. That he has a condition, certain condition. What are the condition? That he can invest a maximum amount of rupees 50,000, or the storage capacity of the space is it can occupy only 60 pieces. It may be a 60 tables or it may be a 60 chairs. So the maximum storage capacity is 60 and maximum amount he can invest is 50,000. Then how can he invest? So as I said, the maximum amount he can invest is only 50,000 and the storage capacity is only 60 pieces. So this is the storage capacity. So I'll write here, this is the investment and this is the storage. Now suppose the cost of one table is rupees 2,500. Then number of tables he can take. So number of tables he can take is 50,000 divided by 2,500, that is equal to 20. Suppose the cost of one chair is rupees 500. So when I say 500, number of chairs he can purchase. Number of chairs he can purchase is 100. So we know that the storage capacity is only for 60 pieces. Suppose he purchases in the condition like, for example, if he purchases 10 tables or 50 chairs, or we can say it has 20 tables and 40 chairs, it varies. So his investment can also be divided in by the number of tables as number of chairs. Now, if he sells one table, his profit will be 250 rupees. And if he sells one chair, his profit will be 75. Suppose we doesn't know how many chairs or how many tables he has purchased. Let X be the number of tables. Then the total profit will be equal to 250 into X. And similarly, if 75 is the profit by selling the chairs and Y is the number of chairs, Y is the number of chairs, then for each chair you will get a 75 rupees extra as a profit. Then the total profit will be 75 into Y. And here the total profit in terms of table as well as chairs. That is, he can buy all the tables so that Y becomes 0, or he can take all the chairs so that X becomes 0, or he can take both table as well as chairs, and thus the linear equation become 250x plus 75y. What does this indicate? This indicates the total profit. So we are going to perform the linear programming problem for this linear equation, and this linear equation is called as objective function. And here, as I said, there is a restriction of amount as well as the storage capacity. So whatever investment he can make. So the cost of one table is 2,500. So for X table it is 2,500x, and for one chair it is 500. So we have 500y less than or equal to 50,000. So this is the maximum amount he can invest taking tables as well as chair. So you can take only chairs, he can take only tables, or he can take both, but the maximum amount he can invest is rupees 50,000. And similarly, the storage constraint. So how many number of tables, how many number of chairs he took, that we don't know, but maximum capacity or the storage capacity is only 60. So here we are going to solve this linear equation using this linear constraints. We call them as linear inequalities. By solving this linear inequalities graphically, we are finding the solution for this linear equation. What is the solution? The solution is finding the maximum value or minimum value. So thus we can say that finding the maximum value or minimum value of a linear equation subject to the constraint. So these are the constraint. As I said, X is the number of tables and Y is the number of chairs. Both are positive. So based on that linear constraint, so finding the solution or finding the value for a linear function is nothing but linear programming problem. So here, as I said, the dealer has a maximum investment of 50,000 and a storage capacity of only 60 pieces. Thus, this linear programming problem can be formulated as, so here we are finding his maximum profit by investing 50,000 rupees. So that is why, how did he invest money in order to get maximum profit? That can be formulated with the help of linear programming problem. And how we are going to write it? So we will write like this. So that is maximize Z is equal to 250x plus 75y. So this is the linear function which we are going to find the maximum value subject to constraint. Subject to constraints. So what are the constraints we have here? So we have two constraints. One is investment constraint. And the other one is storage constraint, that is x plus y less than or equal to 60. So now here you can see the first equation, we can also reduce it. So if I divide both sides by 500, you will get this as 5x plus 5 less than or equal to 100. So this is the linear equations you get. Now here, as I said, we are going to find the maximum value of z. How we are going to get it? By the help of graphical method. So in our first PUC, we have learned how to find the solution for linear inequalities by graphical method. So here we have certain set of linear inequalities. We are going to find the solution. Solution is nothing but you are going to find the solution region. So we are going to find the solution region satisfying these two linear inequalities, and from there we are going to find the maximum value of the given function. So as I said, the example which I have taken can be stated mathematically as maximize z is equal to 250x plus 75y subject to the constraint 5x plus y less than or equal to 100, x plus y less than or equal to 60. What is this? X greater than 0, y greater than 0. X represents number of tables, y represents number of chairs. So when I say number, it means count. So inequality says they are greater than or equal to 0. So therefore, it also indicates in a graph that when I say x greater than 0 and y greater than 0, the solution will be in our first quadrant. So thus what we can say here, we have to maximize the linear function z subject to the given constraint determined by a set of linear inequalities. So these are linear inequalities. We are going to find the solution satisfying both the linear inequalities and find the maximum value of z. So such kind of problem is called as linear programming problem. And in linear programming problem, some definitions are very important. The very first one is objective function. So what is this objective function? The linear function z, where you are going to find the maximum value or minimum value of that equation is nothing but objective function. Generally, we express z as ax plus by. Next one, constraints. So as I said, we will have certain constraint to solve the linear functions in terms of linear inequalities. So here, these are the constraints we have. So according to the example, we have investment constraint as well as the storage constraint. So these are the restriction to solve this linear equation. So therefore, constraints are nothing but the linear inequalities or the linear equations, or we call it as a restriction on the variables of a linear programming problems is called constraint. The next one is linear programming problem. So what is this linear programming problem? A problem which seeks to maximize or minimize a linear function in terms of variables x and y. Generally we take x and y subject to certain constraint determined by the set of linear inequalities is called linear programming problem. Now as I said, here we are going to find the solution for linear programming problem by graphical method. So since we already know how to find the solution for set of linear inequalities by graphical method, half of the problem is done. The remaining I'll explain you later. Now let's see, let's take the same example here. So here we are finding the graphical method of solving linear programming problem. So let me take this as an example. Maximize 250x plus 75y subject to constraint 5x plus y less than or equal to 100, x plus y less than or equal to 60, x greater than 0, y greater than 0. So this clearly means we are taking only the first quadrant. Now here we have two inequalities. Find the solution for this. So first let us take 5x plus y less than or equal to 100. So usually we take it as equal to find the points. So to solve equation here, let me take this as x and y. If you put x is equal to 0, you will get y as 100. If you put y is equal to 0, you will get x as 20. So therefore, the points for this is 0, 100 and 20, 0. Now let us take the second equation. We have x plus y is equal to 60. So again we have x, y. So we take x is equal to 0, y is 60. We take y is equal to 0, x is 60. Now clearly we got the points here. So what are the points for this one? We have 0, 60 and 60, 0. So what is the next thing? To solve the linear inequalities, we will draw the lines for this linear inequalities. So for that purpose, we will take x-axis and y-axis. We will consider x-axis, y-axis and the origin. So since the values are in tens, we can take coordinates in the form of 10, 20, 30, 40 like that. So here, I'll take the value in terms of 20, 40, 60, 80, 100 and here also I can take 20, 40, 50, 60, 80, 100. We can also take in the form of 10, 20, 30, 40, 50 also. So taking different scale is okay with this function. Now here we can see for the first set of linear equality, the solution is 0, 100 and 20, 0. So we have 0, 100, 20, 0. So draw a line for this equation and write the equation of this line, that is 5x plus y is equal to 100. For the next one we have 0, 60 and 60, 0. So this is the set of line we have. What is the equation of this line? X plus y is equal to 60. Now, as I said here, since we have less than or equal to for both the linear inequalities, that means the solution lies below the line. So for both the lines, the area below the line indicates the solution region, which is the region where the area coincides for both the line. So here you can see for this region, so here will be the solution and for this region also, this is the area. So here you can see the shaded region represents the solution region for the set of linear inequalities. So for both the lines, it should be below the line. The area below the line represents the solution for the given set of linear inequalities. And here, which area coincides the solution for both the region? So this quadrilateral is the solution region for both set of linear inequalities. So until here, you know how to find the feasible region for the given linear inequalities. Next, what I am supposed to do, that is, I need to find the maximum value for the linear equation z is equal to 250x plus 75y. So what is the next thing I am going to do? So once you find the feasible region here, mark the corner points of the feasible region where the edges meet. So these 4 points will be the corner points. They are called as corner points, and write their coordinates. So for origin, it is 0, 0. I'll mark this as A. So what is A? 20, 0. So when you draw this in graph, you will get this as 10, 50, and this is point C, whose coordinates are 0, 60. So once you got all the corner points, you are going to substitute in a table. So what is that table? We call it as a corner point table. So we have 2 columns here, where the first column contains the corner points and the second column contains the solution for the linear function. So these are the 2 columns we have here. Now here you are going to write all corner points. So what are the corner points here? We have origin 0, 0, A 20, 0, B 10, 50, C 0, 60. So once you write all the corner points, the next thing is you should substitute value of x and y by taking the coordinates. So for the first one, x is 0, y is 0. So when you substitute here, the whole equation becomes 0. The next thing is you have A as 20, 0, that is 250 into 20 plus 75 into 0. So where you will get the value as 5000. Next, put 10 and 50, you will get the value of 6250. Next, you have 0 into 60, x becomes completely 0. 75 into 60, you have 4750. So now, what is my aim? My aim is to find the maximum value. Which is the maximum value? Here, this will be your maximum value. The maximum value is represented using the capital M. So, what does it indicates here? So, the dealer, after investing his money of maximum of 50,000 and with his storage constraint that he can store only 60 pieces, how many tables and how many chairs he can take by taking the maximum profit? The maximum profit he can get is 6,250. How? By taking 10 tables and 50 chairs. So this is how linear programming helps us to decide what we should do to take maximum profit, and also it helps us to decide about the minimum cost. So when he is ready to invest a maximum of 50,000, he can also get 6,250. He can also get 5,000 as a profit, but see, he can purchase only 20 tables. He can take 4,750 as a profit, but he can take 60 chairs, all 60 chairs. But when he takes 10 tables and 50 chairs, he will get the maximum profit. So this helps us to decide what to do to get the maximum profit. So this is how we are going to find the solution for a linear programming problem. So the first thing is, whenever any linear programming function is given, we have to formulate it. What is the linear function? What are the constraints? Then we have to solve the linear inequalities and find the solution using the graphical method. Once you find the feasible region, mark the corner points, substitute in the table, solve it for the linear function and find the maximum or minimum value what they have told. So the same graph you can observe here. So this is the graph which I have taken in terms of 10 here. So this is the line 5x plus y is equal to 100, x plus y is equal to 60. I have marked the corner points here clearly. So then I have substituted it in the corner point table where you will decide the maximum value. So therefore, the maximum value of this linear function is 6250. Now, few more definitions are necessary to know. The first one is feasible region. What is this feasible region? Once you find the solutions or a graph for the set of linear inequalities, the common region which satisfy all the linear inequalities in the linear programming denotes the feasible region. For example, previously the shaded region which satisfy both inequalities gives you the feasible region. Next is feasible solution. So what is feasible solution? So the points in the feasible region. So it may be on the corner or it may be inside the feasible region. Those solutions are called as feasible solution. That is, the points within or on the boundary of the feasible region is called as feasible solution. The next thing is infeasible solution. So what is this infeasible solution? Any point outside the feasible region are considered as infeasible solution. Next, optimal or feasible solution. What is this optimal solution? Optimal solution is a point for which you will get the optimal value, and optimal value may be maximum or minimum. For example, so here the point B10, 50 is the optimal solution. Why? Because you are getting the maximum value at this point. So therefore, the point where you will get the maximum value or minimum value, which also called as the optimal value, is called as optimal solution for the linear programming problem. Now, let us take few linear programming problem and find the solution. So the first one is maximize z is equal to 4x plus y subject to the constraint x plus y less than or equal to 50, 3x plus y less than or equal to 90, x greater than 0, y greater than or equal to 0. Again, this is nothing but our solution lies in first quadrant. So let us find the solution for these two linear inequalities. The first one is x plus y less than or equal to 50. So the solution is x, y. For x is 0, you can get y as 50. If you put y as 0, you will get x as 50. So the solution for this linear equation is 0, 50 and 50, 0. So you can plot this point in a graph and draw a straight line for this equation. Next we have 3x plus y less than or equal to 90. So here we have x and y. Put x is equal to 0, we'll get y as 90. Put y is equal to 0, we get x as 30. So therefore, 0, 90 and 30, 0 are the points for this second linear inequalities. Now plot the points on the graph and draw a line. So this is how we will get the solution region. So see here, the first point is 0, 50. So this is the point 0, 50 and 50, 0. So this is the point 50, 0. Draw a straight line using your scale and write the linear inequality. So that is x plus y is equal to 50. Since you are drawing the line, just write equals there. The next solution is 0, 90 and 30, 0. So take 0, 90 and 30, 0. Draw a straight line for the equation 3x plus y is equal to 90. Now, for both the inequalities, I have less than or equal to. That means the solution will be below the line for both the inequalities. So we know that, so below the line means this will be the solution for both. And here also it will come here. So, but which is the region, which is a common region for both? This is the shaded region. So the shaded region which is in blue, we can say it as a feasible region. Now again here, This has to be drawn using your graph sheets only. So a graph sheet will be given for you. So you have to plot the points for each inequality and draw a straight line and then shade the feasible region. So half of the problem is done. What is the next thing? The next thing is we are going to mark the corner points of the feasible region. What are the corner points of this feasible region? One is origin. So this is point, and this is 1 point, and this is point. And write their coordinates. So what are the coordinates here? So for origin, it is 0, 0. So A is clearly 30, 0. B you will get from the graph. So it is 20 and 30 here. So clearly X value is 20, Y value is 30. So this will give you the coordinate of B, point of intersection of B. And C is clearly it's 0, 50. So now once you find the coordinates of all the corner points, substitute in a corner point table. Substitute all the points O 0, 0, A 30, 0, B 20, 30, C 0, 50. So once you have written all the corner points, the next thing is you are going to write your linear function. What is the linear function here? Z is equal to 4x plus y. So substitute x and y value by taking the coordinates. So the first one, both are 0, so the value is 0. Second one is 4 into 30, 120, y is 0, so the total value is 120. Third one, 20 into 4, 80 plus 30, 110. Fourth one, 0 into 4 becomes 0, y is 50, total value is 50. So what was the linear programming problem given? So maximize 4x plus y. That is nothing but we are finding the maximum value of 4x plus y. Which is the maximum value of 4x plus y here? That is 120. So this is the maximum value, which is also called as the optimal value. If this is our optimal value, which is our optimal solution? 30, 0 is the optimal solution. Hence, we are going to conclude it. So, therefore, the maximum value is 120 at A 30, 0. So, this is how you are going to find the solution for the LPP. Next one. Minimize and maximize z is equal to 3x plus 9y subject to the constraint x plus 3y less than or equal to 60, x plus y greater than or equal to 10, x less than or equal to y and x comma y greater than or equal to 0. So, our aim is to find both minimum value as maximum value for this linear function. What are the constraints we have? X plus 3y less than or equal to 60. And let us find the solution for this. Let us write the solutions in terms of x and y. Find the coordinates. Put x is equal to 0. Y you will get it as 20. Put y is equal to 0. X you will get it as 60. So what are the solutions? 0, 20, 60, 0. So using graph, plot this point and draw a straight line for this equation. Next we have x plus y is equal to 10. Again here also find the value for x and y. Put x as 0, you will get y as 10. Put y as 0, you will get x as 10. So what are the points for this line? 0, 10 and 10, 0. So this is the solution. Again plot these 2 points. Draw a straight line joining these 2 points. Next we have x less than or equal to y. So this one we can take it as x is equal to y only. So thus we can write the solution for x and y. So x and y. So if you take whatever the value for x, y value is same. So if I take x as 10, y is 10. If I take x as 20, y is also 20. Similarly, you take any values for x, it will be same value y. So thus this is a straight line passing through the origin. Now, so this is the graph you will get after plotting each point and drawing respective lines. So for the first set of equation, that is x plus 3y is equal to 60. The points are 0, 20 and 60, 0. So these are the points. So draw a line for this. For the second set of line here we have 0, 10 and 10, 0. So that is x plus y is equal to 10. Now for the second set of equation again, so here they have taken 5, 5. We can also take 10, 10. You will get the same point here. So write the equation as x plus y is equal to 10. Now for the third set of linear equation, as I said, whatever the value of x, the y has the same value. Hence, it is a straight line passing through the origin. So that is for 5, 5, 10, 10, 15, 15, 20, 20, that will be the solution. Now, observe the equation here. So for the first equation or the first set of line, here we have less than or equal to. So that means the solution region lies below the line. Next, for the second equation, x plus y is greater than 10. So this is the line x plus y greater than 10. That means the solution region lies above the line. And for x less than y means this is the line x is equal to y. Less than y means the solution will be behind this line. So which is the region which satisfies all the conditions? This is the region which satisfies all the conditions of these three linear inequalities. So therefore, shade this region. So this region is your feasible region. So once you find the feasible region, mark the corner points. So here, what are the corner points here? Clearly you can see here, I have taken this point. So that is 0, 10. This is the point where 5, 5. This is the point, it is where 15, 15. So you will get the distance of point from both x-axis as well as y-axis, which will give you the coordinates of the point. And this is the point 0, 20. So once you have written all the corner points, again substitute in the corner point table. So here I have taken all the corner points. What is my linear function given? 3x plus 9y. Substitute for x and y. 0, 10 means 0 plus 90, 90. 5, 5 means 15 plus 45, 60. 15, 15, so total it will become 180. 0, 20, again it becomes 9 to the 180, so total. Now here, we are supposed to find both maximum as well as minimum values. Now write both minimum as well as maximum value. It is a minimum value, so this is the minimum value. And what are the maximum values? Here we have maximum. So therefore, maximum value of Z is 180 at C 15, 15 and D 0, 20. So similarly, minimum value of Z is 60 at B 5, 5. So this is how you are going to find both maximum as well as the minimum value. So the solution of finding the maximum value or minimum value by linear programming method involves the following step. So whenever the statement is given, first we need to formulate in terms of linear programming problem. If it is already formulated, so no need. So first thing is we need to formulate it. That is, we have to convert the mathematical statements into mathematical formulas. That is, writing the linear inequalities, writing the linear function and the constraints. Now the next thing is, whenever it is already in the mathematical form, not necessary to formulate it again. The next thing is, we need to find solution of inequalities graphically. So that is, we are going to write the solution through graph by plotting the points and drawing lines. The next thing is finding the common region. So that is also called as feasible region. So once you find the feasible region or the common region, so you are going to find the corner points. So finding the corner points, so corner point table, we'll take it in all the corner points in the corner point table. So solve z is equal to ax plus by. So once you get the coordinates of all the corner points, you are going to solve the linear function. So the last thing is find maximum or minimum value. So these are the steps you have to follow to solve any kind of linear programming problem. So for your examination, there will be 1 questions on linear programming problem for 6 marks. We'll meet you in the next session with few more linear programming problems. Until then, keep watching, keep learning, keep exploring. Thank you.